Okay, so here we are looking at what would it take to adopt NDE 4.0. And let's take the ecosystem perspective. Real quick, NDE 4.0 is non-destructive evaluation in the era of fourth industrial revolution. I imagine by now you would have figured that one out. This journey actually for me started in 2018, but Norbert coined this term back in 2016, and Johannes Vrana, who was my partner in this activity, he started talking about this in 2017. So about 3 years ago, we all sort of came together and we have been together learning this subject and sharing our learning pretty much in real time with the NDT community. We have come to a point where we now need the technology community to join hands and to take it to a point where as an ecosystem we can all benefit. So I'm sharing with you this perspective today, and in about few months, maybe 3 months, 6 months, we are going to bring out a transformation guidance so that anybody who is in the area of NDE 4.0 could take that document and plan their roadmap, plan their technology activities, plan their transformation journey using that guidance. Later today, you will also get to hear from Johannes Vrana a slightly different perspective about NDE 4.0, where he's going to share with you how structural health monitoring, sensor technology, and NDE 4.0, they are all coming together to serve one purpose: safety, quality, reliability. Anyway, so as a community, I would like to say thanks to a lot of people who have helped me. It's very difficult to count everyone, but I think I go across 10 or 12 countries. COVID brought us closer because we were able to have video conferences and Zoom meetings, and we have all sort of come together to learn this subject a lot more quicker, faster, better. For those of us who may still be wondering, what am I talking about? The four industrial revolutions have been Industry 1.0, which was triggered by steam, Industry 2.0, triggered by electricity, led to mass production, Industry 3.0, around computers and automation, and Industry 4.0, which is around cyber physical systems. There are people who are beginning to talk about Industry 5.0. I think there are two areas where that fits. One, academic research, or maybe other research houses still looking for, always what's next, and they might be thinking of Industry 5.0. But let's be careful. There is another class of people who are using Industry 5.0 as a terminology to just market themselves and in the spirit of, I know more than others. But I think me, Rippy Singh, and my partner, Johannes Vrana, we believe that Industry 4.0 itself has not yet unfolded itself. We are yet to see all the glorious things that are going to come out of the fourth revolution, what they're going to bring. And we have not yet faced all the challenges and all the negative side effects that Industry 4.0 will bring. So from industry and application perspective, we hold the view that we would like to limit ourselves to Industry 4.0 and not jump into 5.0 at this point. What is the biggest difference between 4.0 and the previous revolution? The second revolution, we learned how to handle physical stuff, how to handle materialistic stuff. In the third revolution, we learned how to handle digital stuff, the computer stuff. But in the fourth one, we have learned how to connect the two. In this revolution, the sensors pick up the real-time data from the physical world, bring it into the cyberspace, into the digital world, into what we call as a digital twin. We'll process the data, we'll do the predictions, we'll do the simulations, we'll understand where the physical system is going, be able to predict. And take certain actions and compute what should be done and take the control back into the physical world to close the loop so that the physical, digital, physical works in real time in sync with each other. And that's where the term digital twin comes up. Digital twin is a little more than just computer model, but it's a computer model which is carrying as many physical parameters and is completely aware of the physical reality in real time and is able to control the reality in real time. That is what differentiates fourth revolution from the third revolution. When people say, oh, we've been having robots, we've been having computers, we've been simulating these things for a long, long time, there's a difference. Yes, we have been simulating, but that simulation and the reality, the loop is now beginning to close in real time for the benefit of society. From NDE perspective, from inspection perspective, the physics is still the same, but the digital tools are continuously developing. And that's what differentiates. It requires a different focus looking at the involvement of digital systems in our life. The various digital technologies, the portfolio is pretty enormous. We talk about 3D printing, we talk about 5G, we talk about artificial intelligence, drones, edge computing, IoT, quantum computing, virtual reality. This list was 8 or 9 technologies about 6 years ago. Now it is 17. I think 2 years from now it'll be 25. And some of us will look at it differently. Either way, this is a growing portfolio, and we have to adopt, learn, accept, and leverage the power of digital tools. From NDE perspective, the oldest way, even 2000 years ago, we used to see when things failed or when they were about to fail using our senses. We still do that at home. We still do that in workplace. That's the basic perception detection that we use. Vision, ears, those are the two most powerful ones. Then came the time of NDE 1.0 when we started saying, can I enhance so that I can see what my naked eye misses? Fluorescent particle came around, mag particle came around. You can have a stethoscope, you can have magnifying glass. The NDE 2.0 allowed us to go deeper inside. So the second revolution in inspection world was, can I see things which are hidden? Can I see behind the wall? Can I see what is inside the box? The third revolution in the NDE world happened when we were able to put computers and take those images into the digital world and be able to email and be able to simulate and be able to share, superimpose, analyze, predict. All sorts of digital processes came about that point. And now, the fourth one, we are able to bring the digital physical world in closer. So that's what is the fourth revolution about. Not just being able to see what is happening, but being able to predict what will happen and then being able to see what will happen right when, where in physical reality overlapped. That's what is the fourth revolution doing for us. Why do we want this? Well, why do we do inspections? Why do we do NDE? We do NDE to avoid failures. We do it so that we don't have situations like this. Actually, my career started with Aloha, but that's now too long ago. We don't use those pictures anymore. This is a more recent one. We look at it so that we can assure safety of products in service, and we can assure quality of products when they are being produced. What happens when you're going through a revolution? Normally we say you can handle safety, cost, speed, availability, only 2 out of the 3. You can either be faster, cheaper, but not safer, or you can be faster, safer, may not be cheaper. But when you are going through a revolution, it is actually possible to do all 3 together for some time. Again, once we stabilize within the fourth revolution, we'll always be compromising, picking up 1 or 2 out of these 3. But right now, for the next few years, we have an opportunity to develop systems that can make our products safer, cheaper, faster, better. So, as these revolutions have evolved, how they have assured safety for us? Long ago, human senses, intuitive, live and learn. Then came the time when we started using factors of safety. And then NDE came about. So it was a lot precautionary at that point. Then came the time of safe life and fail safe. NDE started becoming more important. It was still, the whole idea was, can we prevent a failure? Then came the era of damage tolerance. I want to be able to predict the failure and inspect based on certain known inspection interval, based on predictive crack growth to assure safety. That topic has been on our minds for about 3 decades. I have had a significant portion of my career focused on building damage tolerance capability. What will NDE 4.0 do to us now? It can take us to prescriptive handling. I don't have to necessarily create a safety inspection program which is common to all assets. I can prescribe for every individual asset. What do we mean by that? What's that promise? That promise is coming from, I create a digital twin of an asset number of a specific aircraft with a specific tail number. I use communication tools. I use 5G to capture inspection data, to capture SHM data. I bring it all and store it on digital twin, from where I am able to do simulations. I am able to predict damage progression. I deploy artificial intelligence to run what-if scenarios. And then I use augmented reality to visualize what's happening. So much data, so much information, so much knowledge, and ability to visualize and see the future in digital world overlapped on physical world. So I can prescribe what should we do and not do with that particular asset. I can have a very prescriptive maintenance repair program. I can 3D print spare parts and tools so that I get the benefit of cost, availability, and safety all at the same time. What I've done is connected the physical world with the cyber world, still keeping the human in the loop, so that NDE is no more a cost center. The investments you make in sensors and maintenance actually generates data that creates value. That's the promise of NDE 4.0. What will it do? Think about it. Any product, trains, airplanes, whatever, there's an asset OEM who goes through a design, prototype, production, then starts putting these assets in service. And then, of course, at the end of service, they can be repurposed, reused, retired, recycled, whatever. And we do inspections, non-destructive evaluation throughout the service life, throughout the production phase. So we have it. And for many, many years, actually, I think for hundreds of years, when the development team builds a prototype, they put all sorts of sensors. They are essentially doing non-destructive evaluation in real time while they're testing. And that data is used to refine the design. Then when it goes to production, you have lots of quality checks all along the production value stream. And that data also is fed back to improve the design. So this is how an asset manufacturer actually takes the data from the physical world, improving the product performance. When it comes into service, we have an inspection plan. Most of the time, inspection plan was given by the OEM. Sometimes the owner-operator modifies it to meet their requirements in consultation with OEM. But you create a plan and then you start doing inspections at regular intervals based on the plan. When you do the inspection, you discover something, you learn about how to improve your inspection. The inspector learns how to reset, how to calibrate, how to improve the little inspection domain that that individual is focused on, gets through a continuous improvement loop all the time. Okay? The inspectors are getting better, the equipment is getting more comfortable, the application, the understanding of the application is getting better. Some of us now are also beginning to take that data and see if you can adopt the plan. When you get into schedule pressure, cost pressure, you start looking, are you over inspecting? Are you under inspecting? You figured something out, you learn, you realize, you change the frequency of inspection. You put in different NDE equipment. So owner operators actually do have a loop to some extent using NDE data to replan. This is where additional value can be created. If we can take NDE data and bring it back all the way to the design team. So the digital twin, if that can feed inspection or performance data back to the designers can improve on their product. That loop right now is very, very weak. And if you were to think of CAD models starting from design and slowly becoming a digital twin, and the digital twin going into service and capturing in-service inspection data, while the OEM still has access to the digital twin, then the asset OEM can pick up real-time performance data from the asset and think about improving their product, improving the next generation of whatever they're designing and making. Let's look at another piece, the NDE inspector. That may be an employee of the owner operator, or that may be coming to you through a service business. Now, to some extent, the NDE data is being used to help inspectors get better at their job. But we can also think about the service provider as well as the inspectors collectively using the data, feeding back into the plan and integrating that service business with the plan in a manner where as the inspector competency gets better, it can be used by the owner operator to readjust their plan and make it more cost effective. Improve the performance, improve the safety, improve the dependability. All of those things that we talked about, they can create additional value. The NDE data can create additional value for the owner operators when processed by the service providers in a certain manner. What else can NDE 4 do for us? Think about the companies that are making the NDE equipment, the NDE equipment OEM. They go through equipment development and application validation. Now I could take the same NDE data from the digital twin of the product, combining it with the digital twin of the NDE equipment, and bring that data back to help improve the plan. Think about it. The inspector and the inspection equipment are a part of the system. And in that system, we can have data-based improvement for both of them. Of course, this loop with better NDE equipment may not happen as fast as with the inspectors it could. But there is an opportunity where the NDE equipment developers use the field data through the digital twin in a manner to have high performance in their equipment, in their next generation of equipment. And oh, by the way, they don't have to stop at just helping owner-operator replan. They can be a part of the design cycle for the product. Now that way, the asset designer can think of, I have so much data about performance of the product in service, of the inspectors who are inspecting, of the NDT equipment. How can we leverage all of that to further improve the asset design? Now you are suddenly going to a level where you can extend life affordably. And you can derive value out of inspection programs in a manner that was not possible up until now. So the NDT will suddenly go from a costly thing to do, an undesirable thing to do, to something that actually generates data of value. That's the whole promise of NDE 4.0. This NDE, even at the end of the service, if you have all of the data, you can figure out which components, subcomponents can still be used, what part of your aircraft or oil and gas plant can be repurposed before we create more garbage for the planet. We don't have to dump the old stuff. We might be able to reuse it. So there is some element of sustainability that NDE4 will bring for us. By the way, the number of loops that I'm showing over here are few. You can have very large number of loops. You will see that with Johannes's presentation later today. Loops can be back feeding, loops can be forward feeding, but many more loops are possible. What does it mean? You know, this conference is all about smart structures. A smart structure is where you have a sensor and actuator within the system so that as the sensor picks up something, the structure begins to adopt its behavior. But what I'm showing you here is a much larger structure. It's an ecosystem. I'm showing you an organizational structure. I'm showing you actually multiple organizational structures. And what I'm saying over here is that NDE 4.0 can take your smart structure, fit it in an organization so that your organization now gets smarter. Okay? You have an opportunity with NDE 4.0 to create a smart organization structure. So NDE 4.0 as an ecosystem where the data becomes the environment. And in that ecosystem, the four major players are organizations that built the asset, the aircraft manufacturers, the rail manufacturers, the oil and gas plant builders, the dam construction guys. Then there are owner operators who are responsible for a day-to-day operation, bringing that service. You know, if this is Boeing, an owner operator could be Delta. And then we have inspectors who are actually performing the inspection using an equipment built by the OEMs, NDE equipment OEMs. But there are other players. There are R&D centers, universities, there are regulatory certification bodies. Then there are inspection service providers, inspector training schools. They're also a part of the ecosystem. I didn't touch upon those explicitly because they do not have their own closed loop cyber physical, but they are a part of somebody's loop. They need to play along. They need to understand what it means to have a cyber physical system. And then, of course, there are people like Rippy Singh who are, who have some insignificant influence because we come to conferences and flop our jaws and share with you what we don't know. So there are a lot of other insignificant influencers that are a part of ecosystem, but they still need to float around because sometimes they connect the dots. Each entity in the ecosystem has its own reason why they should be a part of NDE 4.0. And they probably have slightly different role to play in bringing the subject to life. But they all have to adopt it to their place, and their adoption may be a little different. You know, if you go back to the loops that we talked about, if you really have to work in the loop, it's like a chain. Everybody in the loop must understand what their role is. Otherwise, the data does not flow. It breaks down. It's like plumbing, right? It must be continuous. If it's not continuous, it leaks somewhere else. So that makes each one of these ecosystem members to be mutually dependent on each other for success. If we believe that NDT equipment guys will go to Industry 4.0, will make NDE equipment which has got all the AI, machine learning, virtual reality built into it, but inspector says, I don't want to wear the goggles, I don't want to read this, I don't trust the machine learning, it's not going anywhere. And if the inspector is ready to wear goggles, but they are not connected to the equipment, they show him or her nothing. So that's what I mean by an ecosystem perspective where data actually becomes the environment. Data is going to flow just like water, just like air, and it might need its own regulation. And that's a problem that we need to solve. But we need to think of NDE4 as an ecosystem of data flow. There are lots of valuable things that can come out of NDE 4.0. I already mentioned a whole bunch of them. We can enhance inspection capability and reliability. We can improve efficiency and effectiveness of inspections. We can improve the NDT equipment. We can improve inspector safety. You can use drones and robots so that inspector does not need to go into hazardous environment. NDE can be simplified for everybody. Start using mobile devices. Create an app that engages very quickly. The quality assurance on the shop floor, the quality assurance of 3D printed parts. So like that, there is no upper limit to how far we can go to extract value from NDE 4.0, where everybody wins. However, it all feeds on NDE data. There are big challenges to adoption. There are technology challenges. We still need to work on connectivity. There's a talent workforce development challenge because it's very heavily dependent upon IT. We still don't know how to deal with ethics of learning systems. It needs a new kind of leadership. It needs a new kind of workplace acceptance. And there are unknown human factors. I don't know how you will behave when robot is your boss, or when you are sitting in a boardroom making a decision and there's a machine over there like Alexa sitting on the table which has an opinion. And that's based on data. And it's actually a good opinion. Will we accept it? There are human factors associated in co-working with intelligent machines, which we are yet to understand. So there is a lot that we here still to think about, still to bring to life. And then all of this will have to go through validation, certification, regulation, adoption. It's going to be a long journey. It could be a few years long. There's a significant amount of uncertainty and ambiguity. The end of this is not clear. We have to create it. And that's why we are not yet ready for NDE 5.0. Because I don't even know where NDE 4.0 is going. We all have to do this together. When I was growing up, during my early career, I learned going together is better. But when you are going through a revolution, I think together is the only way. It's not just better, that's the only way. We have to work and think like an ecosystem. We have to work together. And that's what Johannes and I have been doing. We are working hard to bring people under one umbrella. Right now of ICNDT. We have 17 countries as of now participating. And we hope to bring more guidelines on how to take that journey. We are coming together in 2 months, actually in 1 month, in April, at the first international conference on NDE 4.0. It'll be virtual, it's in Germany. We are bringing documents. Before the end of the year, you will see a handbook of NDE 4.0, which has 75 contributors, 1,500 pages of useful content, and something smaller for us to use, a small book on World of NDE 4.0, and of course, even smaller set of guidelines that I've mentioned twice before, which will have a more input and coordination from around the world leaders on this topic. Last year, we started a YouTube channel which is free to subscribe just to educate the community on NDE 4.0 and just to build the momentum. We need your help. Please join us in that journey. Before I close, I would like to share with you, NDE 4 is here to stay. The question is, who should you hire? If you want to be a leader, you need a Chief Innovation Officer. If you want to follow a leader, you need a Chief Risk Officer. But if you want to stay on the sidelines and just be an observer, you need a Chief Prayer Officer. Because this train is coming at us fast and furious. And we need to prepare for it. We need to embrace it. We need to adopt it. And some of us need to lead it. With that, I conclude my presentation. And I'm here if you have any questions for me. There's a lot more coming in the afternoon with Johannes Rana. But for now, Thank you for listening. Bye.